So the first type of metabolism that we're going to start with is anaerobic glycolysis. And so when we're going through anaerobic glycolysis, we're going to be located in the cytosol of the cell. And we are using glycolysis to metabolize a glucose molecule. Now, if we're thinking about the storage form of glucose, that's called glycogen. And that can also be used during glycolysis. Keeping in mind that glycolysis is really only for carbohydrate metabolism. So you will never go through glycolysis when you're metabolizing a fat molecule. So when I start off, I always draw my two arms that I'm going to go down when I go through glycolysis. And at the start, I'm going to have to put in 2 ATP molecules. So you have to put a little bit of energy in to get a lot of energy out. When I write the word 2-ADP, this is the low energy form of ATP after the phosphates have been cleaved. So those little arrows, it's what's going in and then what's coming out. Importantly, I'm using phosphofructokinase as my rate-limiting enzyme. So when there's a high amount of ATP, that's going to slow down the reaction. And when we have a high amount of ADP, our low energy metabolite, then that's going to speed up the reaction and help us produce more ATP to be used in muscular contractions. So now let's take a look what happens through the rest of this metabolic process. So as we go down each arm of metabolism, we're going to put in 2 low energy molecules and we're going to get out 2 ATP on either side. Remember, we've taken a 6-carbon molecule and we have 2 3-carbon molecules on each side. I'm also going to produce 2 NADHs, one going down each arm. And my end product of glycolysis is going to be 2 pyruvate molecules. So my next question has to be, do I have oxygen available? In which case it would be aerobic metabolism. Or do I not have oxygen available? In which case it would be anaerobic metabolism. And this is an important question to know, and you would know this answer in a question that was given to you, because it's going to determine the fate of what happens to the pyruvate molecule. So in this case, we're going to say that we're going through anaerobic metabolism. So no oxygen is available. When you don't have oxygen available, pyruvate is converted to lactate. And you're familiar with lactate from the burning sensation that you feel in your legs when you do heavy exercise, which is the hydrogen ions that are associated with the lactate. And that conversion from pyruvate to lactate is controlled by lactate dehydrogenase. That's the enzyme. And that can allow pyruvate to go to lactate or lactate to go to pyruvate. Now, importantly, this requires energy. So we're going to use these NADH molecules produced earlier, and we're going to put them into that reaction, and we're going to get the low energy NAD as a product of that reaction. So we no longer have these stored NADHs to be used for later. They've been used up in that reaction. So our net ATP production whenever we metabolize a glucose molecule, if you look, we've got to put 2 ATP in, we get 4 ATP out. And so our net ATP that we're going to get in this specific reaction is going to be 2 ATP molecules. Now we could have also started with glycogen, our storage form of glucose that's always already packaged nicely for metabolism. And if we start with a glycogen molecule, then we don't put 2 ATP in at the very beginning. We only have to put in 1 ATP at the beginning. So that means our net ATP is going to be minus 1 ATP plus 4 ATP, which is going to give us 3 ATP.